Hello and welcome. I am doing a live test run today of one of the cases for the South African Excel Championship 2024. This case is called Game of Life and it is by Jason Weber. And I've heard of the Game of Life, but I've never played it, so I don't know. Let's see how it goes. So let's see what we got. Rules tab sets out the rules for the game. The rules only become applicable from level 5 onward. Okay. Level 5 is also considered easy and is used to introduce the rules. Okay. Wait, how many levels are there? Uh, okay, it only goes to 7. Okay. The Grid 10 tab contains a blank grid which can be used to test and answer the case questions if needed, not an outright requirement. Okay. Designed to change color when... Okay, got it. Grid 100 is similar. All right, so we got... There's a grid and there's a grid. SAEC 2024. Okay. And we got a bunch of rules here. Oh, this is, sorry, I thought this was a board. This is like Conway's Game of Life. Oh, cool. Oh, cool and maybe terrifying, but cool. Okay. All right, so let's see, how many active cells are there on grid 100 before any turns? Is that just the sum of... Ah, for some reason my thing is not auto-completing at full speed at the moment, which is very annoying. Wait, where? I don't see that many active cells. I only see a few. That isn't... What? I'm confused. Oh, wait, no. What is going on here? Am I just grossly missing? Okay, no, fine. I guess I'm just underestimating how. All right, fine, whatever. 138, done. Uh, Grid on the bonus 2 tab has a horizontal line and it known as an oscillator or a blinker in the Game of Life lexicon. Applying the rules after 3 turns, will the line be horizontal or vertical? Okay. All right, hang on. Let me. It's a good time to look at the rules. Okay. So, populated active, empty inactive. Other act. Oh, got it. Okay. So each cell with 1 or no neighbors dies. Each cell with 4 or more neighbors dies. Each cell with 2 or 3 neighbors survives. And cell with exactly 3 neighbors becomes populated. Any other number remains empty. Okay. This is going to be an interesting one, but okay, fine. So in other words, after 1 turn, it'll go vertical, after 2 turns horizontal, and after 3 turns vertical again. So I'm just going to say, will the line be horizontal or vertical? I guess I just type in vertical. Considering all of the text strings provided in levels 1 to 7, excluding examples, there's one string which is duplicated. What is the string? Level 5 does not have any text strings and can be ignored. Okay, so they're not all in the same column, I think. Or are they? Let's see. Okay, so let's see, we've got 1 to 120. So we'll do B3 sequence 120. And we want to XLOOKUP this in here B, returning from here H. We should have a string there, not there. That's good. So then let's just do countifs. This is this. Not 100% sure this will work because these are very long. If they're being treated as text, it'll work, and if they're not, it won't. But okay, there it is. So what was the question? The string or the game number? What is the string? Okay. How many active cells are there in all the text strings provided in level 1 to 7, excluding examples and before any turns are taken? Level 5 does not have any text strings and can be ignored. Okay. So, it really would be easier if I could just get rid of level 5 from this. So let's do that. So I want up to 70 and then 81 to 120. So let's just do vstack. Ugh. Slow autocomplete is incredibly frustrating. It just happens every now and again. And sequence from sequence. Come on. Oh my god, I'm gonna lose my mind if this keeps up. Of 40 starting from 81, I think. And that's still Same answer there. Good, does. Okay. So then I just want, I guess, columns. Lots of different ways to do this, but I'm just going to do this. Regex extract this. 1, 1. Okay. Ugh. Killing me. Anyway, fine. How many active cells? I think that's right. Okay, and using grid 100 with these cells active, how many cells are active across the entire grid after 10 turns? Ooh, that's going to be a fun one. Okay. Given a string of text represented as active and inactive, how many active cells are there? All right, so let's do this a more sensible way this time. We'll do len, oh my god, I hate this. Len pause minus len pause tab substitute pause tab this. So we're going to get rid of all the ones and see how much shorter it gets. And that is working fine. Next. You're given a string of text representing active and inactive cells in a 10 by 10 grid. Assume first 10 characters of the text string represent row 1. Sure, makes sense. How many active cells are there in the row specified? Okay, so this is pretty simple. We can just say mid of this sequence. So in the row specified, meaning we're going to, the first 10 of the first row, yes. So it's going to be a sequence of 10 numbers starting from this minus 1, minus 1. So in other words, this minus 1 times 10 plus 1 is going to be the starting point. So in other words, for row 1, you get 0 multiples of 10, and you start at 1. For any subsequent row, you add another 10 to where you start, and 1. And that gives me my 10, and then I just want equals 1, and then convert those trues and falses into numbers that I can sum. Oh, sorry, I saw 3 and thought I'd got it wrong, but no, 5 is the answer, 3 is the input. Good. All right. Next. You're given a string of text representing active and inactive cells in a 10 by 10 grid. Apply the text string rules you know from the previous levels. Is the specified cell active or inactive? Okay. So I think what I want here is a row of indirect of this. So I'm just going to do row col position. So we'll do column of indirect of this. So then my position in the string, similar to before, is going to be row minus 1 times 10 plus column. And then we just want mid, that string, that position, and 1. So, sorry, what's the question? For your answer, use 1. Okay, fine. Just assume we multiply by 1. We'll say value. Wait, ooh, hang on. Ah, ha, ha, ha. Would you look at that? We have an empty row and an empty column. So this needs to be minus 1, and this needs to be minus 1. Okay. We're jumping around. Okay. All right, next, level 4. You're given a string of text representing active and inactive cells in 10 by 10 grid. Apply the text string rules you know from the previous levels. How many active neighbors does the specified cell have? Okay. So, slightly tempted. I do have a prepared lambda. It's been one of my favorites, like my original kind of one of my first that was a little more complicated than just like here's a list of dice or look something up, and it takes a grid and it takes a range of like how far away from the starting cell to get, respecting the edges of the grid. So like if you start in a corner cell, it won't go up and to the left, but it will go down and to the right, and then applies an operation to the cells in that range. So it would do this very nicely, but I feel like when I'm not competing, I ought to try to do things from first principles so that I'm not being so flipping silly. So how am I going to do this from first principles? So first, I think I'm going to want to split this. And how are we going to do this? I think we're going to say I want to split it out into the grid that it should be, and I think I can do that with two sequences. So we'll have a sequence of the row numbers, which will be 10 counting down, start at 0, steps of 10, plus sequence of the column numbers, which will be, so I'm skipping the first argument there so that it counts across, and then 1. And if I just drop the mid for a second, you can see maybe a little more clearly what's going on here. So this is a handy little kind of Excel feature called broadcast, which is, I've got this sequence which goes down a column. I've got, actually, sorry, I can't let's put that one back and get rid of this one. I've got this other sequence that's going across a row, and if I add the two of them together, it basically expands the column out into a 2D block, expands the row down into a 2D block, and then sums them. So this is the sequence of things in order. So mid that 1, and that's that, and then let's just do times 1 to be safe. Now, I guess I might be better off to just have this as sequence 100. Have it flat. So then let's start building up. So this is going to be my, no, I won't. I'm never entirely sure when I'm doing these cases that I'm not competing in. Am I trying to, practice and be competitive? Am I trying to be instructional? I mean, first of all, game of life is just an awesome topic. So I think I am inclined to kind of slow down and try and be a little more instructive in this one. But I reserve the right to change my mind later. So that's one thing. Now, basically, my thought process is I'm going to use a trick that Bo often uses, which is to apply values to the grid that are, let's say, 1, 2, 3 across here, and then something like 101, 102, 103 across here, because that way, if I want to look at, I can then kind of flatten that out to have numbers along each of these. And the point of having it go up in steps of 100 rather than steps of 10 is that it means, so basically a column offset, going one column to the right means adding +1 to the index number, going one column to the left means subtracting 1 from the index number, up a row means -100, down a row means +100. But the nice thing about having bigger gaps between the rows is that, for example, if I'm on the left-hand side here and I go to the left, if my indices are dense, so whatever this is, I don't know, the 41st cell, then if I go to the left, it would tell me, okay, well, this is the 40th cell. So you go to the left from here and it takes you up to here, it wraps around. Whereas if there are gaps, then if I go to the left from here, I get an index that isn't in there. So if I go to look up an index and find it absent, then that will tell me, this is a cell that doesn't exist. Because the challenge of kind of summing the neighbors is that you have to respect the edges. So like if you're in a corner here, you're only summing 4 cells. If you're in the middle here, you're summing 9 cells, and so on. So that's a bit of waffle, but that's the idea. So the way I'm going to do that is to call sequence comma 10. So in other words, counting across up to 10 plus sequence 10, starting at 0 and in steps of 100. And sorry, I'll not do the to call first, so you can just see that then gives me that grid that I described of 1 to 10, then 101 to 110, and so on. And then I can flatten that with to call. And so now the idea is that, from any given place, I can go, to get my neighbors, I can go -1, 1. I can go, sorry, it should be -100 to go up 100, and then -1, 1, and then I can also do combinations of these. So let's just do it. So -101, -99. So in other words, -100 to go up a row, +1 to go across. This one is going to be +99, and this one is going to be +101. And I'll put in a 0 in the middle as well. So I am going to, let me just flatten that out. And I'll flatten it as a row, I guess, because then I can, well, you'll see what that lets me do in a second. So I'm just going to name that dirs for directions. So then here I can say this plus dirs. These are the the up to 9 cells that are accessible from here. So as you can see, 1, 2, 100, 101, and 102. Sorry, not 100. 1, 2, 101, and 102 are the valid references. And one way you could check that is to say X match this against here, and it's going to give you error, 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 valid, valid, error, valid, valid. Okay, so now we're almost at a stage where we can make sense of this. So now I'm going to, rather than just adding the 1, this is why I wanted to flatten my directions into a row rather than a column or leaving them as a 2D, is I can now add that to this. So now I've got a 2D array that is all of the neighbors, including possibly invalid references of a given cell. And now I want to XLOOKUP that in here in my index column, returning from my values column that says, is it active or not? And that gives me a bunch of errors, which I guess let's put something in there. Let's just put a double quote in there. And then, so here, for example, I can see three active cells. Now, keep in mind that the cell is a neighbor of itself. But I think I could just remove. Just gonna just to keep my options open, I'm going to do both. I'm going to filter dirs where dir is not equal to 0, and I'll call that ndirs, neighbor directions. So for this, at least, I'm interested in neighbor directions because I want to know how many active neighbors, I think was the question. So now that we have this, the blanks are contribute nothing to a sum and the zeros contribute nothing to a sum. So if I just sum each row here, that'll give me my answer. So I want by row sum. And if you're not one of the lucky people that has eta-reduced lambdas yet, you can say lambda row sum of row. But oh, they're so good when you get them. It's one of the few new features that like doesn't actually let you do anything you couldn't do before at all, but is still wonderful. Anyway, okay, so now I need to just convert C6 into a reference, and what's the easiest way to do that? I think it's just to say, well, all right. So I'm going to have to start putting these together now. So let flat grid be this, then. Whatever, just give me flat grid for a second. And then my index is going to be this. Ind this. Turning ind. And then this. Going to be biro xlookup ind plus ndirs in ind returning from flat grid. So, and that gets me all the way to there. And then I just need to convert this. So then, my mouse is, oh, okay, here we are. So we'll call it nsum for neighbor sum. And then call it ref, can be indirect of this guy. And then finally I want index nsum by row number, so it's going to be redo column of ref plus row of ref minus 1 times 10. There's a problem. What is the problem? Could you be more specific? Oh yeah, I'm missing a comma here. And that gives me 3, and that agrees. All right, so look, I'm not going to lie. You could flatten this out into a grid and go like find C6 manually a lot faster than I just did this. But like I said, I'm slowing down and trying to be instructive. So, all right, that's level 4. Now, level 5. Level 5 onward, the rules about cells becoming populated, active, or empty, inactive after a turn apply. So you're given a starting state of a cell, as well as the number of neighbors the cell has. After one turn, is the specified cell active or inactive? Okay, so that's pretty simple. If it's, sorry, here's the rules. If it's active, then it needs 3 or 4 neighbors. And if it's inactive, it needs 3. So it's going to be Inactive needs 3. So let's just do or. I want to avoid or, actually. So say if this equals active, then this equals 3 plus this equals 4. The logic of plus here is this equals 3 will return true or false, this equals 4 will return true or false. And if you tell Excel to add up two trues and falses, it says, okay, you must want to think of these as numbers, so I'm going to convert trues into ones and falses into zeros. So these can never both be true, so when you add them both up, you'll either get 1 if at least one of them is true, or you'll get 0. And then otherwise, I want this, so if we are inactive, then this has to be exactly 3, I think it was. Now here I'm just going to put minus minus or 1 times in front of it, so again just do some operation to it to convert the true or false into 0 or 1, and let's just quickly check there. But alright, so that's level 5. Level 6, you are given a string of text representing active and inactive cells in a 10 by 10 grid. Apply the text string rules you know from the previous levels. How many cells are active across the entire grid after 1 turn? Okay. And then presumably we want to go on from there after 3 turns. And then we want to go on and apply something to the bigger grid as well. Okay. So whoops. Sorry. Okay. So obviously to me, the obvious move here is to make a lambda that will take this text string and convert that into its next step. So we've got a pretty good start on that already up here. Up here. So where are we gone? Why am I here? Okay. So let's grab this and come on down. So first things first, is this the actual example grid? Because that would definitely be helpful. Let's find out by saying mid of this. Actually, wait, I can go do it on grid 10. It'll be more obvious. Mid of mid pause tab of this sequence comma 10 plus sequence 10 comma 0 10. Oh yeah, sorry, comma 1. And that's strange, they have all turned yellow. Okay. We'll say if this equals 1, then 1, otherwise 0. Will that help? Yes, okay. So my question was, is it that grid? And the answer is yes, it is. Good, wonderful. Okay, so now I don't need this ref nonsense anymore. So I just need to figure out the next state, and that is going to be if flat grid, meaning if the initial value is a 1, then I want not in but nsum, the number of neighbors equals 3 plus and number of neighbors equals 4. Otherwise, I want 1 times number of neighbors equals 3. I think that's it. We've basically done the work. So let's return wrap rows of next by 10 to see if it looks like this. So sorry, let's just bring these values over here. Does it look like that? Where are we going? No, it doesn't. It does not. Shoot. Okay. I guess my first thing is, am I wrapping it right? Not 100% sure of that, but 0011, yeah, no, it's not the wrapping that's the issue. So I'm getting this wrong, but I know I must be pretty close. So let's do wrap rows of nsum. So it says we've got 2 neighbors here, but we do not. First cell does not have 2 neighbors. Ah, for the love of, because I haven't updated this reference. Okay, so now let's try wrapping next. There's a special kind of skill required to be able to be smart enough to write this function and stupid enough not to update the reference when you copy it down from one level to another. But anyway, okay, so let's put that in here, and that does look at least somewhat more like this thing. No, it's still not right. Huh, okay. First things first, are there any other references? No, there aren't. Okay. So next question is, so if it's a flat grid, I want 3 or 4. Otherwise, I want 3, yes. So let's do a wrap on n sum. So this has one neighbor. Let me just see. Some ones I'm getting wrong. So I've got 1, 2, 3, 4. What's going on here? 4 zeros and then 3 ones, and that's good. But then I'm supposed to have 1, 0, 1, not 0, 0, 1. That's not right. This cell has 2 neighbors. So that should die. I think my answer is actually right here. Okay, that sums to 35 though, so it's definitely not matching. Okay, well, let's try this. Let's take the original wrap rows flat grid. I'm just gonna look at it because with a game like this, that's actually relatively doable. So this does not have enough neighbors. This does have enough neighbors. This does. This does not and will die. This will die. No, sorry. This will not be born because it has 4 neighbors. That has 2 neighbors, so it will die. That has 3 neighbors, so it'll stay. 3 neighbors is fine. This one has 3 neighbors, so it'll be born. This one will not be born. Too many neighbors. This one has enough. Yeah, I think my answer is working here. So let's take one more look at this. Yeah, I think this must be a mistake. Like, these 2 will definitely die. They're all by themselves. Let me just read the rules one more time carefully. If a cell has 1 or no neighbors, it dies. Oh, wait. Oh, sorry. So 2. Sorry, I want 2 or 3, not 3 or 4. Ah, okay. Stupid. All right, so 2 or 3, not 3 or 4 for an active one. And does that then start to look a little bit more like the output? It does. No, it doesn't. Oh, sorry, that's because I'm still echoing the input instead of... Well, it's a good thing that I said I was going to slow down and be instructive because I'm making a complete mess of this. But anyway, okay. So that's good. I think we've got it now. So now we're just going to say sum of next. And that is 37. Okay, so now I probably don't, maybe I have time. I have 2 minutes. That's not really time. I did talk for a minute before I started going. Let's see, I don't think I'll get level 7 done in the time, but on the other hand, it would be nice to try. So what I want is lambda of strt, and sorry, I guess I need to define this. So let stp, so this is my lambda that's going to take a step, is going to be mid of strt, blah, 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 and then the output is going to be concat next. Then I want stp, I want reduce of this sequence, sequence 3, stp. Will that work? No. Just 1? No, doesn't work at all. That's unfortunate. So let's see. Not sure why that isn't working. All right, well, I'm definitely not getting it done in the 30 minutes anyway. Although I guess the obvious thing when I only need to go 3 flipping steps would be to just, don't need to do reduce. Just do this and say concat. So that'll put that back into the format of that. And then to, ooh, what? Yeah, well, it would help if I pointed to here. 2, 3. Oh, maybe I didn't update that. Anyway, sorry. Too late for that. Okay, so it's that. Then I want len of this minus len of substitute this 1 blank. And that gives me, what, 24? Yes, that's the right answer. All right, cool. So maybe I did just about make it. But I will not be happy until I have a more proper solution to that. But for now, let's go, time's up anyway, but let's go and do the last level. How many cells are active across the entire grid after 10 turns? Okay, so I do need to get my stepping lambda working for this to make sense. So let's try and get that working now. I don't need to, I could just bash it, but this is more elegant. So I want lambda of strT. So actually first let input be, let's just, rather than reconcatenating it and re-splitting it out again every time, let's just take this. Yeah, so I guess we just start with one flat grid and go to the next. Let input be that. Then let STP be this lambda, which takes a start, or I guess takes flat grid, and does all this stuff to it. Let's just okay. And then I think I just, in this case, want to output next. So I take the flat grid, I compute the, the index is just a constant that I can take out. That doesn't need to be defined every time in the lambda. So given a flat grid, I calculate the neighbor sum. That makes sense. I calculate the next step, just like that, and then I return next. That's good, I think. So then let's just try STP of, it's not auto-completing that, which is not a good sign. Oh no, that's just because it was going very slowly. Fine. STP of, oh wait, sorry. Yes, of input, because I've already taken one processing step. Okay, what? Oh, sorry, yeah, because it's trying to spell it. That makes sense. So let's just do concat so I can look at that for a second. Ugh, stupid lack of autocomplete. Concat of STP of input. And let's just that over here where the output was, and we can see if that still gives 24. No, it gives 31. Oh, yeah, because I've only taken one step, sorry. That makes sense. So then now we want to reduce input 3 steps by applying STP. What? What? Why? Oh, because STP only, that's the problem, because it only takes one flipping argument. So we'll just add a second optional argument called non-arg and see if that, yeah, it does make it considerably happier. So now let's just concat that so that we can get it back in the ground. That does give the 24. Okay, so now the only thing is I need to put in one more variable here, which is size be 10. And then instead of 100, I'm going to want size squared. Instead of 10, I'm going to want size. Instead of 10, I'm going to want size. Instead of, here I guess I'll want 10 times size. That's, I think that's all fine. That's all fine. That's all fine. That's fine. Size, and then num steps, which in this case is 3, but I want to be able to vary that. So num steps. Okay, and in this case, I'm actually interested in the sum, not the concat. So if I put that there, that should then reproduce all of these results, and it does. Hooray. So now I should be able to answer the bonus question, finally. So let's go and grab all of this. Again, probably would have been faster to just build 10 grids, but I like to do things interesting ways as well as just the fastest possible way. So, so my input here is just going to be to call grid 100. My size is going to be 100. My steps is going to be 10. And ooh, that takes a hot minute. I guess it is a pretty big grid. All right, well, anyway, that's going to calculate for a while, but that is my answers. The actual answers are in a different file, so I'm going to have to go and check. But if I got anything majorly wrong, I will post some notes in the video description, just so you don't have to watch me sit around and test and debug. And wow, it's still running. That's would not have expected it to be that slow. I guess probably part of the answer is I could have just run it on a tiny subset in the middle that was much smaller, because there's no way that it'll grow fast enough. Like, it can't move more than one cell per generation, and as sparse as it is, it probably grows much less than that actually. So I could have just done it on a range of 10 around the starting point. But anyway, now that it's running, I feel compelled to wait it out, but I won't make you watch me do that. So that's what I got for today. I will post in the video description whether this got the right answer or not. But that's what I got. Thanks for watching. See you next time. Okay, just a very quick add-on, months later, or weeks later at least, when I'm finally getting around to posting this, to say that my attempted bonus 5 did not work, because although I had the sense to make my sequence flexible and flex with the size of the grid, I forgot that I also would need to make my directions flex with the size of the grid. So I had my set of directions that was like minus 101, minus 100, minus 99, minus 1, plus 1, and so on. But those assumed an offset of 100 between rows. So I made it flexible here, but not flexible here. So that's why that didn't work. But I did come back and fix it, and it did. The same basic idea did work once I set it to big directions. I also tried it another way with my neighbor operation that I kind of mentioned in the video, but I didn't want to rely on it here. But it's kind of perfect for this game, because you can just say on the input grid within a range of 1, give me the sum, and then you can work from there pretty quickly. That said, the smarter way, almost certainly, to do this would have been to, let's just shrink this up, would have been to just do 10 grids of extremely simple formulas. So here's, neighbor sum, the sum of the cells around you, minus yourself, and then you can just say if you're non-empty, then you need a 2 or a 3, and if you're empty, you need a 3. And then just copy that to all 100 rows, 100 columns, and then repeat that for 10 grids. And the nice thing is you can even see it growing when you do that. Anyway, there's lots more I would have kind of liked to say about the game of life, but I don't want to let the great be the enemy of the good. I will say on this approach running super slowly, which it did right at the end there, Bo has done a very cool video exploring ways to gather up a group of neighbors in an efficient way. So you should check that out. That's all I got for today. Thanks for watching. See you next time.